All right, so this is one of the final exam problems. And this is the problem right here. F of x equals 1/2 of e to the x plus e to the negative x, with x being inside of 0 to 1. So the formula we use, and it wants us to find the length of the graph, so use the length formula, which is a to b times, well, the integral of a to b times square root of 1 plus the derivative squared. And so this is how it'd be set up with, 1 plus the 1/2, because it's 1/2 times e to the x and all that stuff squared. And when you do the derivative of e to the x plus e to the negative x times 1/2, it would be the constant times the derivative, leaving you with e to the x, because e to the x's derivative is e to the x, plus negative e to the x, right? So that would leave you with this right here, with 1/2 times e to the x minus e to the negative x, and all that squared. When you square it, you'd have to FOIL it though. However, when you square the 1/2, you're gonna get 1/4. But then you'd FOIL the e to the x minus e to the negative x. And that would leave you with, and here you can see all the steps that I went to just to FOIL it. And you'd end up with e to the 2x plus e to the negative 2x minus 2. In step 6, you'd see that the length formula, we still have the length formula, nothing squared anymore, but you got 1 plus 1/4 times all this e. So how would you simplify this out? Multiply everything by 4 so that you could have this 4 underneath everything, and it makes everything much simpler. So you got 4 over 4, because that one becomes a 4, times 1 times all this. This one is irrelevant, it gets taken out, but I left it there just to show you. Over 4, right? 1 times x, and I even said 1 times x equals x, so this one becomes irrelevant, and I just removed it afterward. And you'd be left with something that looks like this, with, remember, the integral of 0 to 1 times 4. Now you got 4, all of it is just placed under 4. And then we have like terms, so you take it out of the parentheses, take 2 out of the parentheses, and you have, well, the negative 2, and then you have 4 minus 2. Well, that equals 2 right here, and I show it right here. And in this step, step 9, you're going to see that the length of as 0 to 1, you're going to take the, what's it called, the square root of 1/4, which is 1/2, and then take that out, multiply it by the integral, and you're going to be left with this, right? And so now you're going to be thinking, what do you do next? Well, you have 2 plus e to the 2x plus e to the negative 2x. You can't, well, you're not allowed to like add a positive e to the x plus an e to the negative, right? You're not allowed to do that, so you turn this into 1 over e to the 2x, which is going to leave you with this. You don't actually cancel these out just yet. You don't cancel these, but what you're going to do is, it's going to leave you with something that looks like this. 2 to the e to the 2x, because you're multiplying everything, you've got to multiply everything by e to the 2x. And that's going to leave you with something like this. 2 to the e to, just like we did with the 1/4, multiply everything by 1 over e to the 2x. Well, multiply everything by e to the 2x, and you're going to be left with 2 to the 2 to the e to the 2x plus e to the 4x, that's a 4, and then plus 1, all over e to the 2x inside of this radical or radicand, whatever it is, and then multiplied by 1/2 times the integral of this function. Now when you get to here, on this side, when you get here, step 12, you would want to, well, first you'd want to take the square root of this e to the 2x, right? And because e to the x squared is e to the 2x, this is going to sound a bit funky when I say it. The square root of e to the 2x is just, all right, so like I was saying, the camera cut off. But when you take the square root of e to the 2x, you just get e to the x, which is why it's going to be 1 over e to the x instead of 1 over e to the 2x, right? And then you're going to notice that 2 to the e to the 2x plus e to the 4x plus 1 resembles x squared plus x plus 1, which is equal to x plus 1 squared, right? So then e to the 4x plus 2 to the e to the 2x plus 2 times e to the 2x plus 1 would be equal to e to the 2x plus 1, all of this squared. And then L equals, so L will now equal 1/2 times the integral of 1 over e to the x times e to the 2x plus 1 squared all to the root of 2. And then this is going to cancel. So since it's squared, it's going to cancel with the root. And you're going to be left with this. 1/2 times the integral of 1 over e to the x times e to the 2x plus 1. This is going to equal, you can just take this all out of the parentheses, and you're going to be left with e to the 2x plus 1 all over e to the x, right? And then you're going to take the integral of that, and you're going to be left with e to the, well, first of all, the integrals, I have the integral rules right here. So like the integral of e to the negative x is going to be equal to negative e to the x, just to like help me like kind of work through this problem. And then e to the x minus 1 over e to the x. Remember, you're not allowed to subtract a negative, like positive and negative, so you're going to turn this into 1 over e to the x. Since you're not allowed to do e to the x minus e to the negative x, you're not allowed to do that. Like, you're not allowed to do something like this. You just can't subtract this and make it a 0. You wouldn't be allowed to do that. So we turn it into the 1, turn it into a 1 over e to the x. And right here, you're going to take the, all right, so that these are the integral rules. So I just showed you guys the integral rules. Now you're gonna put like 1 and 0 into these functions. This should actually be a negative right here. So this is a negative. That's an e to the negative x, right? And so e to the 1 minus e to the negative 1 minus e to the 0 minus e to the 0. E to the 0 is just 1, so e to the 0 minus e to the 0 is 0, because 1 minus 1 equals 0. And so all of this times 1/2 would be 1/2 times e to the 1 minus e to the negative 1. And remember, we're going to switch this, just like we did here, we're going to switch this to e to the 1 minus 1 over e. And you're going to be left with 1/2 times e to the 1 minus 1 over e times 1/2. I think I already said times 1/2. Then that's going to equal e over 2 minus 1 over 2e, and that's your answer.